Assalamu alaikum students. This is your chemistry class and I'm your teacher Saima Ashraf. In this part you are going to learn the further topics of the chapter 8 chemical reactivity. In this part of the chapter you are going to learn all the topics which are left. You are going to learn the comparison of the reactivity of halogens, oxidizing power of fluorine. You are going to solve the MCQs from the exercise and going to answer the question from the exercise. Please note down the answers on your neat copies. The first topic you are going to learn in this part is the comparison of the reactivity of halogens. What are halogens? The elements in group 7A of the periodic table are called halogens. The name halogen is derived from the Greek words halos, meaning salt, and gen means former, means these are the compounds which form the salts. For example, NaCl is the table salt which we use commonly. In it, Na is a metal and Cl is a halogen. So it means halogens involved in the salt formation. That's where the name is given to them. Halogens include fluorine, chlorine, bromine, iodine, and astatine. Physical properties of halogens. Fluorine and chlorine are gases. The fluorine is a pale yellow gas while chlorine is a greenish yellow gas. Bromine is a liquid. Bromine is a reddish brown liquid while iodine is a bluish black solid. Chemical properties of halogens. All the halogens are reactive nonmetals. They exist as diatomic molecular substances in the free state. Means they exist as molecular substances and the molecule consists of two atoms as di means two. For example, fluorine F2, chlorine Cl2, bromine Br2 and iodine exist as I2. All halogens react with metals and form salts. The salts of halogens with metals are called halides. For example, sodium chloride NaCl, in which the chloride is a halide. In these reactions, for the formation of salt, metals are oxidized, means metal lose the electrons. As oxidation means loss of electron. And halogens are the oxidizing agent because they are helping the metals to oxidize. Means they are helping the metal to lose the electron and they are gaining the electron by themselves. So, halogens are the oxidizing agents because they are helping the metals to lose the electron or oxidize and itself they are reduced means they are gaining the electrons. So, halogens are the oxidizing agents and metals are oxidized in these reactions. Now I am going to explain the reaction of halogens with metals. The first member of the group is fluorine, which is the most reactive element on the earth. It is the strongest oxidizing agent, means it helps the metals to lose the electrons and itself reduce by gaining the electrons. It reacts with metal explosively, means the reaction is very fast, vigorous and leads to explosion. As you can see in the equation, Na, sodium is reacting with F2 and is forming NaF, sodium fluoride. Chlorine is less reactive than fluorine, but it is also a strong oxidizing agent and combined vigorously with metals. For example, the sodium is reacting with chlorine and is forming sodium chloride. This reaction is also very vigorous, very fast, but it is not an explosive reaction. The next member of the group are bromine and iodine. They have less oxidizing power than other halogens and reacts less vigorously with metals. Here you can see in the equation sodium is reacting with bromine and forming sodium bromide, and sodium is reacting with iodine to form sodium iodide. Oxidizing power of halogens. The order of decreasing power of halogens is F2 is the most powerful oxidizing agent. Chlorine has less oxidizing power than fluorine. Bromine is having less oxidation power than chlorine and fluorine, and iodine is the least powerful oxidizing agent. Reaction of halogens with hydrogen means how the halogens react with hydrogen. The halogens react with hydrogen and form hydrogen halides. Here you can see in the equation H2 hydrogen gas is reacting with X2 molecule and is forming HX, where H shows the hydrogen and X is for halide. X shows the fluorine, chlorine, bromine and iodine. Means if the hydrogen reacts with fluorine, it forms hydrogen fluoride. If it will react with chlorine, it forms hydrogen chloride. If it will react with bromine, it will form hydrogen bromide. And if hydrogen will react with iodine, it will form hydrogen iodide. So X shows the fluorine, chlorine, bromine and iodine. The reaction of the fluorine with hydrogen is explosive. Means the reaction is fast and leads to explosion. Formation of hydrohalic acids. The hydrogen halides, which are formed by the reaction of hydrogen with halogens, when dissolved in water, they form the acids. These acids are called the hydrohalic acids. Examples of hydrohalic acids are hydrochloric acid, HCl, means if hydrogen halide, which is HCl, dissolved in water, it forms hydrochloric acid. Hydrofluoric acid is HF. Hydrobromic acid is HBr and hydroiodic acid is HI. All hydrohalic acids are strong acids, but HF, say hydrofluoric acid, is not a strong acid. Acidic strength of hydrohalic acids. This is also the answer of exercise question number part 4, in which we have to arrange the hydrohalic acids in order of their increasing acidic strength. The acidic strength increases in the following order, in which HF hydrofluoric acid is the weakest acid, while HI hydroiodic acid is the strongest acid. Displacement reactions of halogens. Displace means to remove something from its place. In these reactions, halogens displace the other halogens from their place, from their salts. This is also the answer of exercise question number 2 part 5, in which we have to tell that can fluorine oxidize all the halide ions to free halogens? The answer is yes. Fluorine can oxidize all halide ions to free halogens because its oxidizing power is the highest in the group, while iodine cannot oxidize any of the halide ions because its oxidizing power is lowest in the group. Due to relative strength of oxidizing agent, it is possible for a free halogen to oxidize the ion of halogen next to it in the group. Means top member in the group can oxidize all the members which are lower to it. For example, fluorine can oxidize all the halide ions to free halogens because it is present on the top of the group and its oxidizing power is highest. As you can see in all of these equations, fluorine is displacing the other halide ions. In the first equation, fluorine F2 is reacting with KCl and is moving Cl or chloride ion from its salt and is forming Kf and chlorine gas. It means here the fluorine had displaced the chlorine and formed Kf. The next equation, fluorine is displacing bromide ion and is forming potassium fluoride Kf and Br2 bromine. In the third equation, fluorine is reacting with NaI, sodium iodide, and is removing iodide ion and forming sodium fluoride NaF and I2 say iodine. It means that fluorine can oxidize or displace all the halide ions, and chlorine, which is next member in the group, cannot oxidize fluoride ion, but it can oxidize the bromide and iodide ions, which are present next in the group. Bromine can oxidize only iodide ion because iodine is present next to bromine in the group, while iodine cannot oxidize any halide ion because its oxidizing power is lowest in the group. Let's do self-assessment exercise 8.4. In this question, we have to find out that which displacement reactions will occur and which will not. In the first equation, in which the chlorine is reacting with sodium fluoride, chlorine cannot displace the fluorine. That's why this reaction will not occur because chlorine cannot oxidize fluorine because its oxidizing power is lower than fluorine. In the second equation, bromine is reacting with potassium iodide and displacing it. This reaction will occur because oxidizing power of bromine is higher than iodine. So it can oxidize and displace iodide ion. While in the third equation, iodine is reacting with potassium bromide and displacing the bromide ion. This reaction will not occur because oxidizing power of iodine is lower than bromine. So it cannot oxidize and displace bromide ion. In the equation number 4, chlorine is reacting with potassium bromide and displacing it. This reaction will occur as oxidizing power of chlorine is higher than bromine. So it can oxidize and displace bromide ion. In equation number 5, chlorine is reacting with sodium iodide and displacing the iodide ion. This reaction will also occur as oxidizing power of chlorine is higher than iodine. So it can oxidize and displace iodide ion. Now let's do the question from the exercise review question. The question number 1 is we have to encircle the correct answer. The first MCQ, which of the following oxide is the most basic oxide? Strontium oxide. Which of the following oxide is amphoteric oxide? Al2O3, B part. In the third MCQ, we have to tell which of the following elements is the most metallic element. The answer is sodium. In the fourth part, we have to tell valence shell electronic configuration of alkaline earth metals, that is NS2. In the fifth MCQ, we have to tell which of the following metals is not a noble metal. Ag, mercury. Ag or mercury is not a noble metal, while Au gold, Cu copper and Ag silver are noble metals. In MCQ number 6, we have to tell which of the following elements is the least non-metallic element. The answer is silicon, Si. In the 7th MCQ, we have to tell the oxidizing power of which element is the highest. The answer is F2, fluorine. In 8th MCQ, we have to tell chlorine cannot oxidize which of the halide. The answer is fluoride. B, because oxidizing power of chlorine is lower than fluoride. In the 9th MCQ, we have to tell sodium is more reactive than lithium but less reactive than which of these elements. The answer is rubidium, Rb. The last MCQ, in 10th MCQ, which of the following is the strongest acid? The answer is HI, hydroiodic acid. We have done question number 2, all the parts from first to fifth part during the explanation of the part 1, 2 and 3. We have done question number 3 and 4 in the part 1 of the lecture. Now we are going to do question number 5, in which we have to tell that which of the following displacement reactions will not occur. We have discussed the answer of all these equations in self-assessment exercise 8.4. In the first equation, chlorine is reacting with sodium fluoride. This reaction will not occur. In the second equation, bromine is reacting with potassium iodide. This reaction will occur. In the third equation, iodine is reacting with potassium bromide, and this reaction will not occur as well. Write down the answer of all of these questions on your copies neatly. Now the question number 6 from the exercise. We have to tell the important applications of platinum. The answer is on the page number of your book 155. Here you can see the answer, in which there are the uses or important applications of platinum are given on the page number 155 of your book. Please write down the answer on your copies neatly. Now let me explain you the answer of question number 7 from your exercise. What is half reaction? In a galvanic cell, there are two separate compartments, means anode compartment and cathode compartment. Both of these compartments are called half cells. In these compartments, redox reactions occur. Half of the redox reaction, say oxidation, occurs at anode compartment and is called oxidation half reaction. The other half reaction, say reduction, occurs at cathode and is called reduction half reaction. Such oxidation half reaction and reduction half reactions are called half cell reactions. For example, in the galvanic or Daniell cell, the oxidation half reactions occur at anode, as oxidation, which is the removal of electron, always occur at the anode. Here, zinc metal is removing 2 electrons and is forming zinc plus 2 ion. While at cathode, reduction half reaction occurs, means the metal which is present at cathode will gain the electrons. Here, the copper ions are gaining the 2 electrons and are changing into the copper metal, means copper is gaining the electron and reduced during this reduction half reaction. We have done the question number 8. What is aqua regia before during the explanation? So please write down the answer of both of these questions in your copies neatly. Now we are going to do think tank questions. We have done question number 1 from the think tank during the explanation, in which we have to tell that why it is not advisable to pick sodium metal with fingers. Now we are going to do question number 2. This question is related to the topic from the chapter 7, electrochemistry. In this question, we have to tell that how the electrons participate in half reactions. In the galvanic cell, the zinc lose electrons at anode. Because anode is made up of the zinc metal, so zinc lose the electrons and undergo oxidation. Because oxidation is the loss of electron. So this half reactions, the oxidation half reaction occur at anode, in which the zinc lose the 2 electrons, as you can see in the equation. These electrons, which are lost by the zinc, move through the external circuit from anode to cathode. At cathode, the copper ions are present. These copper ions gain the electrons and reduce to copper metal, as gain of electrons is reduction. So reduction half reactions occur at cathode. Now I am going to tell you the answer of question number 3 from the think tank. Design an experiment to show that iron is more reactive than copper. This is a metal displacement reaction in which the iron metal displaces the copper metal. The material required for this experiment is test tubes, spatula. Spatula is a spoon-like object, iron nails, and copper sulfate. Procedure. In the first step, we will mix 1 spatula or 1 spoon full of copper sulfate in 20 centimeter cube or 20 ml of water in a test tube. Then we will place nails, iron nails in the copper sulfate solution and leave for few hours. In the third step, we will look for the signs of pink precipitates of copper. Then we also have to notice the change in the color of copper sulfate solution. The conclusion of this experiment is, or the result of this experiment is that blue colored copper sulfate solution changed to the green colored iron sulfate solution. It means that iron had displaced the copper and made the iron sulfate. And we can also see the pink colored precipitates of copper metal which are settled at the bottom. It means that iron is more active than copper and it can displace it. Now I am going to tell you the answer of question number 4. How are voltaic cells and electrolytic cells are alike and how they are different. Similarities means how they are similar or alike. In both of these cells, redox reactions occur, means oxidation as well as reduction occur in both of these cells. There are 2 electrodes present in both of these cells. One electrode is cathode, the other is anode. And there is an external circuit for the flow of electrons in both of these cells. Now what are the differences between the electrolytic cells and voltaic cells? The first difference is the electric energy is converted into the chemical energy in electrolytic cell, while opposite occurs in the voltaic cell. Say chemical energy is converted into the electrical energy. The second difference is current is used to derive the chemical reaction. Means energy is used to derive the chemical reaction. While in voltaic cell, current is produced due to the chemical reaction. Means electrical energy is produced due to the chemical reaction. Third difference is that the oxidation reduction reactions are non-spontaneous, while in voltaic cells spontaneous oxidation reduction reactions occur. The fourth difference is electrolysis takes place in electrolytic cell, while in voltaic cell electric conduction takes place. Means in electrolytic cell breakdown is occur, while in voltaic cell only the current will flow through the electrolyte. The examples of electrolytic cells are down cell and Nelson cell, while the example of voltaic cell are Daniell cell and fuel cell. Question number 5 from think tank. An iron bar is to be silver plated. Which metal would be the anode and which the cathode? The answer is that during electroplating process, the object which is to be plated means iron bar is taken at the cathode, while the metal used for plating means silver is taken at the anode. Question number 6 from think tank. In this question, we have to compare the corrosion of aluminum and iron. When aluminum corrodes, it forms a tough layer of insoluble aluminum oxide, Al2O3, on its surface. This layer firmly adheres to the surface of metal, means it sticks very firmly, very strongly on the surface of the metal, and thus it protects the metal from further corrosion. On the other hand, when iron corrodes, the insoluble layer of rust is formed. The formula of rust is Fe2O3.xH2O. This layer or the layer of rust is too porous to protect the underlying metal. Means it has pores or holes on its surface and it cannot protect the metal from further corrosion. And this layer also flakes away because it is not a tough layer. And when it flakes away or breaks away, it exposes the metal for further corrosion. So, when aluminum corrodes, it protects the further aluminum metal from corrosion. But when iron corrodes or rust, it cannot protect the metal or further layers of the metal from corrosion or rusting. Question number 7 from think tank. In it, we have to compare and contrast the alkali and alkaline earth metals. Means what are the similarities and what are the differences. First, I will tell you the similarities. Both of these metals are present in S block and both are electropositive. Means they lose the electron and form cations. Both of the metals, say alkali and alkaline earth metals, are very reactive metals. And in both groups, reactivity increases down the group from top to bottom. Mean top members are less reactive and bottom members are most reactive. Their oxides are basic in nature. Alkali metals also form the basic oxides and alkaline earth metals also form the basic oxides. Differences. There are many properties in which the alkali metals and alkaline earth metals show the differences. The first property is physical properties of alkali and alkaline earth metals. Alkali metals are soft and they have low melting points, while alkaline earth metals are hard and they have high melting points. The second property is oxidation state or charge. Alkali metals lose their single valence electron and get +1 charge, while alkaline earth metals lose their two valence electrons and gain +2 charge. Electropositive character means how they lose the electron and they form the positively charged cation. Alkali metals are more electropositive, means they easily lose the electron as compared to the alkaline earth metals. Alkaline earth metals are less electropositive. The fourth property is ionization energies. Alkali metals have lower ionization energies, that's why they are more reactive. While alkaline earth metals have higher ionization energies and they are less reactive than alkali metals. Electronic configuration. Alkali metals have one electron in the valence shell, that's why their electronic configuration is ns1. While alkaline earth metals have two electrons in the valence shell, so their electronic configuration is ns2. Now the question number 8 from the think tank. We have to choose three metals that would not be suitable for coinage. The answer is that group 1 metals are known as alkali metals. They are soft and they are extremely reactive metals. They react extremely or vigorously with water and oxygen in the air. So because of their softness and their reactivity, they are not suitable for coinage. Means if we make the coins from these metals, they will not be hard to handle and they are reactive. Examples of these alkali metals are lithium, sodium, potassium, rubidium, and cesium. All of these metals are not suitable for coinage because they are soft and they are extremely reactive towards water and air. We have done all the topics from the chapter 8. You have to learn all these topics and you have to write the answer of all the questions from question number 1, from review questions till question number 8, and from think tank question number 1 till 8 at your copies very neatly. Stay at home and stay safe and enjoy your vacations.